Remember when you had to find the area underneath any curve, and I'm going to reflect back on last year quite a bit, so I apologize to both of you. I won't say your name. I apologize to both of you because as we move forward in this, it will get a little crazy. But here's basically what you did. If we want to figure out the exact value, how we did this is we said, okay, you're going to figure out the length of your interval, and so how long is this interval? Got to be louder than that. This thing can't pick that up. 3. All right, 3. And what we did was we divided it, instead of by 5 subdivisions or 6 subdivisions, we divided it by n subdivisions. Meaning that we could change that n to be any amount that we want. And we know that the more subdivisions we have, the more accurate this is, right? So we said 3 divided by n, and that meant that what we had to do is we had to find n different heights, ... as we went through this. The way we approached it last year is everything was done from the right-hand Riemann sum, and so today we'll continue on with that. It really doesn't matter whether we do right hand, left hand, or any other form of Riemann sum. They all have their errors, okay? But the idea is that the more subdivisions we have, we eliminate that error, and so it really doesn't matter whether it's to the right or to the left, okay? So today, just to keep everything the same from last year, we're going to go from the right-hand Riemann sum. What that means is that the first bar height would be found at f of 1, okay? And the next one, I'm going to write this down and hopefully you'll understand what I'm doing here. The next bar, so if we're starting at 1, the next one is going to be found 3 over n away from that. Do you follow me on that? Okay. And we could go 3 over n, and we'd go 3, and then we'd have to keep adding that. Does that make sense to all of you? So I actually messed that up because I really wanted to do f of -2 to make it from that side. So I'm going to keep it. Because then the next one would be -2 plus 3 over n. Now let's see if we can remember how to form the next spot. I'm going to drop it here. -2 plus 2 times 3 over n. Yes. And the next one would be f of, and it'd be -2 plus 3 times 3 over n. And the next one would be f of -2 plus 4 times 3 over n. And how many of those would we do? All the way up till we did -2 plus n times 3 over n. Because just like if we had 5 subdivisions, we would do 5 of these. If we had 4 subdivisions, we'd do 4 of them. If we have n subdivision, we have to do n a number of them. And so the n's would divide out eventually, and we'd be left with 1 like the ending number, -2 plus 3. That's how that works out. Okay? Now, what then that meant was we were going to have to take this number and plug it into the equation. Do you all remember this? And so this first one would be 6, and I'm going to write everything out just so that you can see every detail of it, would be 6 times -2 squared. Plug it in. Here we go. Plug that in. The next term would be 6, and we'd have -2 plus 3 over n squared. I'm going to keep calling. The next one from there, hopefully you follow this. Okay, I'm still recording, yes. 6 times -2 plus 2 times 3 over n. Now, you're saying exactly what I need to do. We need to look for patterns. What is something that is appearing in every single one of these? Every single one of them has a 6. So the idea is, I'll use this color first. You've got your 3 over n on the outside from here, right? You're going to take a 6 out because it's appearing in all of them. You good with that? Okay. Now you want, with all that's in you, you want to take a -2 out, and you want to take that 3 over n out because it's in every one of them. But why can't you? Does anybody know? Because it's squared. So before I do anything with those, understand that what I have here is I have things that are squared. And so we can't do that. But I can simplify this. Okay, we can simplify this. Do you all remember doing these? Maybe not. What this looks like is this is the same thing. What's happening is this is the summation, see if we can remember this, of -2 plus, I'll put the 3 over n, and we put the k here. Do you all remember this? As k goes from 1 to n. Are we good? Now what we did from here is we multiplied this out. So -2 squared would be 4. You have the -2 times 3k over n. That makes -6k. It happens 2 different times. So that makes -12k over n plus 9k squared over n squared. From here, you have still 3 over n. You have the 6 out in front. Yes, you could multiply them out, by the way. Okay? At this point, what we did was we then said, all right, I'm going to distribute the summation, if you remember. That's, in essence, what's happening. Not mathematically correct, but in essence, that's what's happening. Everybody's going to get that summation. And so what we have is, we have 4, right? The summation of 4, and I'll write it out long here, minus, I'm going to, summation of 12k over n plus the summation of 9k squared over n squared. Does anybody have any thoughts as to where we go from here? What do we do next? Everything that we wrote down about that key. Exactly. We're going to plug those in. And since you have them written down, I'm going to use that. So what this, are we all okay that this is 18 over n out in front now? Is everybody okay? All right. So what I have then is this is 4 times the summation of 1. Okay? So this is 4n. Good. Minus, this is 12 over n, and this is the summation of k. So what's the summation of k? Plus 9 over n squared, summation of k squared. That's the 1/3 n cubed. Is it 1? I haven't done this since you guys did. 1/2 n squared plus 1/6 n. Oh no, tomorrow's the shortcut. We do 1 day of this, okay? 1 day. That's all I'm asking for. And tomorrow we get right into the shortcut very quickly, okay? So, next step, you got to combine like terms. I'm going to leave that 4n out here. We've got minus 12 divided by 2. That's 6n. Good? Remember, this is a -12 over n, so divided by this 2 is just -6. I'm not going to do that yet, but eventually. Okay. Plus 9 divided by 3. 3, your n squared cancels the 2 of those, so that leaves me with a 3n. Plus, we have 9 halves. That's not pretty, but n squareds cancel out. That's as nice as that goes. Plus 9 over 6. I'm kind of hoping that you all are all right with the fact that they both can be divided by 3, leaving you with 3 over 2. And can somebody tell me where the n goes? Does it go in the top or the bottom? It goes in the bottom because the n squared was in the bottom. Okay? So pay attention to that. still, from this point, and Emily and said that if you got to substituting in the summations, you're set, because from here it's algebra. Now it's just combining stuff that's alike and going from there. So hopefully you all see you got 4n minus 6n, which is negative 2, plus 3n. That's just an n. Negative 6 plus 9 halves. If you have to, remember that's the same thing as 12 over 2. So does everybody follow that that's negative 3 halves? Good? And then you have the last term there, 3 over 2. And what do I do next? Distribute through with this 18. 18 over n, and this n leaves me with 18. The n's divide out. Right? 18 minus, or times, excuse me, the negative 3 halves is negative 27 over n. Yep. You have 18 over n times negative 3 over 2. The 2 goes into 18, giving you 9, negative 27 over n. All right, now 18 over n, we've got another 3 halves. That's a positive 27, right, over n squared. You good with that? For those that had this before, as n goes to infinity, as the number of subdivisions increases to infinity. Yes, sir. As this goes to infinity, we know a number divided by infinity is 0. He's exactly right. These are in essence 0. What were these called? Can anybody tell me what these are called? These are the error terms. So if you had one subdivision, it would tell you exactly what you should get for Riemann sum. Do you all recall that? Nice. Because as n goes to infinity, that's what you're left with. What does that mean? This is the exact, right? This is the exact value. We just found what the integral was from negative 2 to 1 of 6x squared dx. That's what you have. Now, that was a long process. You can see why when Riemann did this, he's like, whoa, there's got to be some pattern to this. There's got to be something to this. And there definitely is. There definitely is. Tomorrow we're going to examine that even more in depth. I'm going to pause this video here and continue on with class. So